I'm going to generate a new function using the average rate of change formula on a generic function of x. What I'm going to start by is looking at 2 points on the graph, point 1 and point 2, and I'm going to apply the average rate of change. Now, what's unique about this situation is I'm not going to assign any values to these points because I have no scale. So, from a function, I'm going to talk about the first point. It has an x value and a y value. In function notation, since I don't know the formula, I'm going to call it simply f of x, which means the y value or output of the function when the input is x. So, as I begin my formula, this is the first point, which again has an x value of x. The next point over here has a separate x value. And again, I don't know what that x value is, but I notice that it is different than this x value. And we're going to talk about, first of all, how different it is. We have moved over to the right a fixed distance. I will call that fixed distance that we moved to the right the distance h. Now, to get the second x value, I'm going to take the starting x value and add h to it. For instance, if this x value was 3 and the distance to the next one was 5, I would say that the second x value was at 8 because I would start at 3 and move 5 to the right and add them together. But since I don't know where this one is and I don't know the size of the distance, I have to use the same mechanics, take the first x value, add how far you are to the right to get to the second x value. So it's all in a generic format. But now I can talk about my second point. My second point has an input of x plus h. It has an output from the function which will be determined by plugging in this value x plus h. So here is my input and this is the output for that input. Now I'm going to apply the average rate of change formula. I'm going to take y2 minus y1 over x2 minus x1. Now, on the top, there's nothing we can do to simplify because we don't know what the y value is when we plug in x plus h. However, I can take x and combine it with a negative x. Those will eliminate each other, leaving me h. So my formula, f of x plus h minus f of x in the numerator divided by h is called the difference quotient. I am now going to use the difference quotient that we just calculated on the function f of x equals 3x squared. First thing I'm going to start off is finding f of x plus h. And I'm going to find that by taking my function and plugging in for the input x plus h. So everywhere I see an x in the function, I will replace that with x plus h. Now I'm going to go ahead and simplify my formula. That exponent of 2 says take this quantity times itself twice. I will now simplify this out using the distributive property, which you may refer to as the FOIL technique, doing first, outer, inner, last, giving me still the 3 times everything, and x times x, x squared, h times x in alphabetic order, and then again the h times x plus h squared. I'll now combine like terms. I have 2 of these hx's. And last but not least, I'll use a distributive property with my 3. And what I have calculated right now is merely f of x plus h. So in my difference quotient, I'm going to start off with the f of x plus h, which is 3x squared plus 6hx plus 3x squared. And then I'm going to subtract f of x, and f of x is 3x squared and I'm going to divide the whole thing by h. So let's take a look at it right now. I calculated f of x plus h right here. I plugged it into the formula. Then I'm subtracting f of x, which was given. All of this divided by h. At this point, I'm just going to combine like terms, simplify my fraction, and reduce. So I'm going to move my camera down a little bit so we can see the work. So I have a 3x squared minus a 3x squared, which will eliminate each other, giving us a 6hx plus 3, oops, that's not an x squared there, that's supposed to be an h squared. I'm sorry about that mistake. So that's supposed to be a 3h squared all over h. I'm going to go ahead and factor the greatest common factor in this case. The greatest common factor of 3 and 6 is 3. The greatest common factor of h and h squared is h. I have no common x factors. So when I factor that out, I get a 2x plus h all over h. Now I will reduce my fraction 1 to 1 from top to bottom. Final answer can either be written in the form 3 times 2x plus h, or in the expanded form 6x plus 3h. So this is the result of applying the difference quotient on the original formula f of x equals 3x squared.